So now let's go ahead and understand the basic structure of our C program. So let me open the code blocks, the project which we created over here. So you need to keep it in mind. So what I'm trying to say here is, let me open the notepad, right? So I don't want to touch this. Okay, so not this one too. Let me close it. Sorry. Okay, there we go. So basically we need to understand C is a structure. C is a structure and the procedure oriented programming language. Oriented programming language, which is basically we have a specific structure to be followed and we have the procedure to execute the program, which means we should keep the header files and we should follow up the main functions at the bottom, right? So header files should be always on the top of it, and we have a very specific order to execute the program. First we have to compile it to figure it out, is there any syntax mistakes over there or not. If that is not, then we need to execute the program. The reason why, it's because we have a several stages on executing it. I will explain it everything one by one, right? Just you have to keep it in mind, C is a structure and the procedure oriented programming language, and C is the mother language. So currently, for most of the popular programming languages which we are using, C is a mother language. The reason why, it's because if you understand the C programming properly, how the control statements are working, how the looping statements are working, what is functions, what is arrays, what is strings, this and that. If you understand this properly, we should able to understand the most popular programming languages like Java, JavaScript, and so on, right? That's the reason C is the mother language, right? And then C is a platform dependent language. Platform dependent language, which means the program which I created over here, if I copy this output file and if I try to put it in another machine, it will not work. So that's the reason it's a platform dependent. The program which you created in the Windows machine will never work on Mac. The program which you created in the Mac will never work on Linux. So it's completely platform dependent. That's the reason. So these are the three main points that we have to understand it, right? So what are the languages that we can understand? As a people, we can understand multiple languages. That depends on the native and the surroundings of the people where we are living, right? But what is the language that the machine can understand? The machine can understand only the machine language, right? The machine can understand. What is the language that the machine can understand? That's the machine language. We used to say it's an assembly language, right? Assembly language. So basically inside the assembly language, what we simply have the binary codes, which is the zeros and ones, which means the machine can understand only the zeros and ones, right? So whatever the code which we are trying to write it in our own specific language, the machine will try to convert it into its own understandable language, which is nothing but the binary codes. That is called object code. And then that object code will be converted back to the source where we can understand. That is our executable file, right? So let me make it clear. So over here, you can see, as I said, we do have this header files, right? So basically these header files are nothing but these are files which contains some predefined functions and classes and all those things, right? Over here you can see we have a method called printf, right? So printf is a function which helps you to print something on the console, right? But who created that printf function and how it's printing something on the console? So to do that, some of the lines have been already returned in some place, right? So someone written some code that printf should work like this. The printf function should print something on the screen. So that line of codes is already written inside this particular header file, right? So that's the reason we need to include that header files first. Then only we can use this printf method, right? So you need to understand that over here at the top, we did hash include stdio.hatch, right? So this is the place where we are including the header files. Over here, you need to understand this hash is the pre-processor operator, and include is the directory name of the folder which contains all the header files, and stdio.hatch, which is nothing but the header file name, which is standard input and the output. This is the header files which carries all the necessary informations which is related to the input and the output, right? So that's the reason we are using the stdio.hatch, and inside we use this method called printf, which is basically helps you to print something on the screen, something on the console, right? And the main function, so basically main is a function which is automatically invoked by the compiler. So that's the function the compiler will automatically triggers it, right? So main function is a function which automatically invoked by the compiler. So that's the function which called automatically. You don't have to call it manually, or you don't have to trigger it. That will be triggered automatically by the compiler, right? So these are the things that you need to understand for the time being. So don't worry about this int, and don't worry about this return statement. We will cover those part later, right? So let's understand how the program it's been executed. What is the life cycle of the program, right? So let's understand that much clearer over here. So I'm gonna create over here. Let's understand this is our source. This is our source, right? So this source will be passed to our preprocessor. So the source will be passed where? The source will be passed to our preprocessor. So this preprocessor will collect all the necessary input files, right? So one second. Okay, so let me bring a text over here. So let's say header file 1. So I need to collect the header file 1. For instance, let's say stdio.h. Then I need one more header file similar to that, which is the strings.h. So these are the header files that will be included inside your preprocessor, right? That will be included inside your preprocessor. So the source code will be passed to the preprocessor, which is basically nothing but the hashtag. So preprocessor has its own operator called hash. That's the preprocessor operator, right? That's the preprocessor operator. You need to understand hash is the preprocessor operator, right? Hash is the preprocessor operator. So our source will be processed to the preprocessor. Preprocessor makes sure all these header files are included properly using this hash operator. Once everything is being included properly, it will be passed to your compiler. From there, it will be passed to your compiler, right? So the compiler makes sure that there is no physical error, which means it doesn't have any syntactical errors. Like you should make sure that you finish every single line finished by semicolon, like you opened and closed the functions properly, like the syntactical mistakes, right? Physical errors. So you need to make sure that it doesn't have any physical errors. If it doesn't have the physical errors, that will be generating an object code. It will generate file called obj, which is nothing but an object code. What is it? It's an object code, the binary codes. That's what I'm talking about. Object code, right? And now, so you need to understand that the compiler will compile the program. It will check for the error. If it doesn't have an error, so only if it is doesn't have an error. If it is having an error, that will be passed back to the source itself. Just keep in mind, if it is having an error, it will be passed back to the source code itself. So let me bring it over here. Yes, if it is having an error, if it doesn't have an error, that will be passed to your object code creation. If it is having an error, that will be passed back to the source code itself. So you need to understand this particular thing over here. All these things will be executed during the stage of compilation. These things will be executed during the stage of compilation. This is the compilation stage. Compilation stage. By the time when you building it, this is the stage where the place where we are building our code, right? This is the compilation stage, which means the source will be passed to the preprocessor, and the preprocessor will pass it to the compiler, and the compiler will compile our code and look for any errors or anything. If it does have the error, it will pass it back to the source. If it doesn't have an error, it will pass it back to the object code, which means our object code is successfully created. And that's the point where we need to move on to the second stage, the stage where we are trying to compile it, run it. This is the stage where we are trying to run our program. This is the execution stage, the place where we are trying to run our code, right? So at that point, what we need is we need the help of the linker, so that the linker will take place. Instead of preprocessor, linker comes in. Linker use this object code. Linker use that object code. One moment. Let me adjust this a bit cleanly. Only one moment, sorry for making it too long. All right, so here, so object code will be passed to the linker. So linker use one more supporting files, which comes from the library files. It's use the library files, the default files, which helps you to decode those object code. So it use the help of the library files, right? So now, which means basically the library files is nothing but the lib files, .lib. File name called .lib. That's the lib file, right? So this is the thing, that's the library files it's using. So library files and the object code files both are combined, and they will be passed they will be combined to create the exe file, right? So both of them will combined, and it will be generating an exe file. Both of them combined, and it's generating this exe file, the executable file. And this executable file later, it will be passed to a compiler, sorry, to a loader. loader. So that exe file will be passed to the loader, then that will gives you the output, the console. So that will gives you the output. So this is the execution stage. So basically this is the life cycle of your C program. So let's have a quick recap over here. So we have two different stages, compilation stage and execution stage. The compilation stage, which is nothing but the place where we are building our code, and the execution stage is nothing but where we are executing our code. So every time whenever you're hitting that build and run option, so the source code will be processed to the preprocessor, and the preprocessor will look for all the header files and make sure everything is included properly using this preprocessing operator, and then it will pass back to the compiler. So the compiler will always look for the physical error, which is basically the syntactical mistakes. If there isn't syntactical mistakes, then it will be passed back to the source code and list out all the errors, the line numbers where the exact error has been occurred. Then it will list out, if that doesn't have an error, then it will be creating the object code file, right? The .opj file. And then by the time when you're running it, the object code will pass back to the linker, and linker will use the help from the library files to decode this object code. Then it will create the exe file. That exe file will pass to the loader. So the loader will trigger that exe file and gives you the output. So this is what happening every single time whenever you are running your C program, right? But if you hit this build and run, how fast you're getting your output. See, this is the execution time of your program, right? How cool it is. So I hope you understand the life cycle and how the way it's been executed, and what is the purpose of main function and what is the purpose of the include and all those things, right? So now let's move on further and understand how all these data types and variables and all those things is being created. So without wasting your time further, let's jump to the next section.